Hello, today we're doing mission 3A, looking at probabilities using proportions. So it says find the probability of spinning a prime number. So prime numbers are only divisible by 1 and itself. So in this spinner, 2 is a prime number because you can only divide 2 by 1 and 2. 7 is a prime number, we can only divide it by 1 and 7. 10 is not prime, we call it composite because we can divide by 5. The only other prime number we have in here is 5. We can divide 5 by 1 and 5, and that's it. So remember, probability is looking for the part we want, or they're asking you, out of the total. So there are 3 out of 1, 2, 3, 4, 5, 6, 7, 8 total choices that would give us the probability of landing on a prime number. So it says, how many times would you expect to land on a prime number if you spun the spinner 90 times? So we're going to take our probability and we're going to set up a proportion. They're telling us, hey, our total is now 90. We need to figure out how many times do we want it to land on this on a prime number if we spin it a total of 90 times. And then we're going to cross multiply. So 8 times x is 8x. 90 times 3 is going to give us 270. And then we're going to divide. This goes back to solving one-step equations. The opposite of multiplying by 8 is dividing by 8. 8 over 8 is just 1. So we get x equals, and then 270 divided by 8 gives us 33.75. Now you can't land a spinner 0.75 of a time, so round up if the number after the decimal is greater than 5. So we would round this to 34. We would expect the spinner to land on a prime number 34 times if we were to spin it 90 times. Now, same question, but different number. How many times would you expect to land on a prime number if you spun the spinner 350 times? Well, our probability is still the same. We still should get 3 out of every 8, but we're going to spin it 350 times. So now that's our total number of times we're spinning. How many times do we want it to land on a prime number? Let's find out. 8 times x is 8x. Cross multiplying. 350 times 3 is 1050. And solving this, the opposite of multiplying by 8 is dividing by 8. So 1050 divided by 8 is 131.25. Now we can't spin the spinner 0.25 of a time, and that's less than 0.5, so we round down or just leave it as 131 times. So we're taking our probability and we're using it to find other experiments, basically. If we're going to do this experiment in a perfect world, how many times should we land on a prime number? Oops. For some reason, our spinner is not showing up here. It says find the probability of rolling, oops, it's not a spinner, rolling a number greater than 3. This was just a dice. And a dice has 6 sides. So we have the options of getting a 1, a 2, a 3, a 4, a 5, or a 6 on the dice. What's the probability of rolling a number greater than 3? Not including 3. Greater than 3, we have 3 numbers. We could get a 4, a 5, or a 6. So that's 3 choices out of a total of 6. The part we want out of the total. Now, how many times would you expect to roll a number greater than 3 if we roll the die 50 times? Well, we could simplify this. This is really 1/2 if we go this way and divide by 3. So half the time we should get a number greater than 3. So how many times should we if we roll it 50 times? Some of you can do this without cross multiplying, because this one may be more of common sense. But if you use the same strategy, 2 times x is 2x. 1 times 50 is 50. And then the opposite of multiplying by 2 is dividing by 2. 2 divided by 2 is 1, 1x. And half of 50 is 25. half of the time we should land on a number greater than 3. Half the numbers are greater than 3. And this next one, how many times would you expect to roll a number greater than 3? So same probability. If you roll the dice a total of 195 times. We're going to cross multiply. 2 times x is 2x. 195 times 1 is still just 195. And then the opposite of multiplying is dividing. 195 divided by 2 gives us 97.5. Now you can't roll a dice or half a time, so you need to round it up. 5 or higher goes up, so it really will land on a number greater than 3 98 times. So you will have some questions just like that on your test where they ask you, or not your test, well probably your test too, but on your homework where you have to find the probability and then use it in a new situation. On the back side, we have a deck of cards, and on yours, I know it's not in color, but the bottom 2 rows are red, we have our diamonds and our hearts, and the top 2 rows are black. We have clubs and spades. So what's the probability of drawing a red? So red is all the ones below here, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 cards in each suit. There are 2 rows of 13. 13 and 13 is 26. Out of a total of 52 cards. For those of you who play cards, we know there's a total of 52. Or you can count 4 by 13. 4 times 13, there'd be a total of 52 cards laid out. If we simplify this, it's really half the cards. Maybe some of you knew that. Half the cards are red, half the cards are black. There's 26 red, 26 black cards. What's the probability of drawing a spade? Our spades, these are our spades right here. There are 13 of them. We have the numbers 1 through 10 or ace through 10, and then jack, queen, king. So 10, 11, 12, 13 out of 52 total cards. And we can actually simplify this. 52 is divisible by 13. There's 4 groups of 13, right? And that makes sense because we have the clubs, the spades, the hearts, and the diamonds. So 1 out of 4 groups are spades is really what it's asking. And then what's the probability of drawing a 5? Well, think, how many 5s are there? Well, there's a 5 in every suit. Clubs, spades, hearts, and diamonds. So there are 4 5s out of a total of 52 cards. We can divide by 4. It gives us 1 out of 13 cards, which makes sense. If you were to just look at one row, 1 out of 13 is a 5. So let's use that information a little bit more. Next it says, what's the probability of drawing a face card? Oops. A face card is a jack, queen, or a king. There are 3 in each suit, and 4 suits. 3 times 4 is 12, or you can count them up. So there's 12 out of 52, and we can simplify. I'm going to divide by 2. That gives us 6 out of 26. Still both even. We can divide by 2 again. And we get 3 out of 13. 3 out of every 13 cards is a face card, which makes sense because if you think of one suit, 3 out of 15 have a face. Next, part B. How many times would you expect to draw a face card if you picked out a card 15 times? I know it's hard to see that a little bit. Got a little funky when I put it in this on my iPad. So we know 3 out of 13 should be a face card. Well, how many would we expect to be a face card if we pulled it out 15 times? So this is going to be pretty close to the actual probability here. So cross multiply, 3 times 15 is 45. 13 times x is 13x. And the opposite of multiplying by 13 is dividing by 13. 13 divided by 13 is 1. So 45 divided by 13, and we get 3.46. We can't pull a card out 0.4 times, so it's really just 3 times. It's pretty close to only pulling it out 13 times, so 15, it's not going to be much different. So what's the probability of drawing a number less than 3? We're going to consider an ace less than 3, and it doesn't say including a 3, so anything less than a 3. The only numbers that are less than 3 are the 2's and the 1's. So we have 1, 2, 3, 4, 5, 6, 7, 8 cards that are less than 3 out of 52. And we could simplify this. I'm going to divide by 4. I know 52 is divisible by 4. We did that earlier. That's 13. And 8 divided by 4 is 2. So 2 out of 13 are less than 3, which makes sense. Think back to just one suit. So how many times would you expect to draw a number less than 3 if you picked out a card 24 times? So same probability, but if we did this experiment 24 times, how many should be a number less than 3? 13 times x is 13x. 24 times 2 is 48. And then our last step, the opposite of multiplying by 13, is dividing by 13. So we have x equals 48 divided by 13 is 3.6, which we would round to 4. 4 times you should pull out a card that is less than 3. If you have trouble with these cards, please make sure to ask. Otherwise, your homework is very similar to what we just did, using the cards on the front side and a dice on the